Given the function f of x is equal to 2x squared plus 7x minus 15, check to see if Rolle's theorem can be used for the function on the interval -5 to 3/2, and if it can, find the values of c guaranteed by Rolle's theorem. So in order to use Rolle's theorem, we need three things to be true. We need this function to be continuous on the closed interval. Well, polynomials are continuous everywhere, so no problem there. This function definitely is continuous on -5 to 3/2. And that's because it's continuous everywhere as a polynomial function. We need for the function to be differentiable on the open interval -5 to 3/2. Well, it's a polynomial function. It is definitely differentiable everywhere, and everywhere definitely includes the open interval from -5 to 3/2. The last thing we need for Rolle's theorem is we need for f of -5 to be equal to f of 3/2. So I'm going to use my calculator here and see if I can figure out what f of -5 is. So we're going to have 2 times -5 squared plus 7 times -5 minus 15. That turns out to be 0. I'm also going to take a look at f of 3/2. So I'm going to take 2 times 3/2 squared plus 7 times 3/2. We'll subtract 15. And I get 0 there as well. So all three requirements for Rolle's theorem are satisfied by this function. So we can find at least one value of c in the interval -5 to 3/2 that is guaranteed by Rolle's theorem. Now remember, what Rolle's theorem says is that we're going to create a secant line that passes through these 2 points, -5, 0 and 3/2, 0. Since they both have exactly the same y value, in this case 0, that's going to be a horizontal line whose slope is going to be 0. Rolle's theorem that says that somewhere in the open interval -5 to 3/2, possibly at more than one place, but at least one place, the derivative of the function will be exactly 0. That is, the instantaneous rate of the change will be equal to the average rate of change of the function over the interval. So we're going to need the derivative. So let's consider f prime of x is equal to 4x plus 7, and let's set that equal to 0. That's what we're being guaranteed, is that somewhere in the interval the derivative is 0. And if we solve that, we find out that x is equal to -7/4. -7/4 definitely lies somewhere between -5 and 3/2, so that is the value of c that Rolle's theorem guaranteed for us.